Welcome to A-Level Physics, looking at power and energy. As electricity is all about energy, there are a few energy and power equations that you need to be able to derive and use. V equals W over Q, so W equals V times Q. The definition of current tells us that Q equals IT, so W equals VIT. Of course, we already know that power equals work over time, which is equal to VIT over time. So power equals VI. We are now going to look at power and resistance equations. From Ohm's law, we know that V equals IR. If this equation is substituted into the equation P equals IV, we can get two new equations. Power equals I squared times R, or power equals V squared over R. We are now going to look at the kilowatt hour. Electrical energy is measured in units of the kilowatt hour, so that people can be charged for the amount that they use. At the moment, 1 kilowatt hour of energy costs about 7p. Energy equals power times time. The kilowatt hour is equal to the number of kilowatts times hour. When supplying electricity to people's home, it isn't important that as little energy as possible is wasted, as electricity travels through the power lines and cables on the national grid. So what is the best way to raise the efficiency and reduce the amount of energy lost in the cables? You know that the greater the resistance of the cables, the greater the power loss, so cables need to be made from good conductors and have as large a cross-sectional area as possible. We can see that the efficiency will be greater when the voltages are high and the currents are low. For example, if a power of 20 MW is to be delivered down a cable with resistance of 100 ohms, is it better to use a current of 20 amps and a voltage of 1 MV, or a current of 2 amps and a voltage of 10 MV? The answer is power wasted in the cable is equal to I squared times R, which is equal to 20 times 20 times 100, which is 40,000 watts. The power wasted in the cable, which is equal to I squared times R, which is equal to 2 times 2 times 100, which is equal to 400 watts. It's clear that for the same power to be delivered, reducing the current and increasing the voltage gives less wasted energy as the current flows to the cable. Transformers are used to step up the voltage from the power station to the power lines and to step down the voltage from the power lines to people's homes. The problem of energy wasted is to be taken into consideration when looking at the applications of electricity. For instance, when transmitting electrical signals for communication, the signal loses strength as energy is lost in the cables.